Okay, so today what we're going to be working on is the normal distribution curve. So I'd like you to put the video on pause and do the try this and then come back and check your answers. Okay, so it says, for each of the following distributions, indicate if it's a normal distribution, skewed, neither, and explain your choice. So taking a look at number 1, or A, the curve looks like this. So this is normal. And why would it be normal? Because it's mounded. All right, letter B. The curve looks like this. So this is skewed right. You also might, you could hear it being said as positively skewed. And why is it skewed to the right? How do we know? Because there's a tail on the right. The data leaves a tail on the right side. Okay, C. This would be skewed left. Or negatively skewed. And we would say it has a tail on the right, on the left, sorry. All right, D, let's take a look at D. D is neither. This is just symmetric. All right, so symmetric is kind of like the same. What's on this side is the same thing that's on this side. And C would be normal because it looks like that mounded shape. Okay, so let's talk about the normal distribution curve. Okay, so the normal distribution curve, which is also called the bell curve, a normal distribution curve has data that has a particular symmetric mound shape, like below. This curve shows the percent or proportion of a normally distributed data set that lies certain amounts from the mean. Okay, so the mean is right here in the middle. So remember, the mean is x bar. So this is called the mean. It's also called the median. And it's also the mode. Remember, the mode is the number that appears the most. Median is the middle number. And mean is the average. All the numbers that lie to the right, that's half the numbers lie above the mean. And half the numbers lie below the mean. Okay, so what else can we say? This is used to calculate probabilities. And it's used to, it measures number of standard deviations away from the mean. And that's also called z-scores. So on the right side, this side, those are positive z-scores. And on this side are negative z-scores. Okay, so flip it over. Okay, so this is what the normal distribution curve looks like, or the bell curve. So obviously it looks like a bell. It has a lot of numbers in here. These are how many standard deviations you are from the mean. So right here in the middle where it says 0, that's your mean value. I'm going to skip all the halves and just go to the whole standard deviations. So this number that would go here, the 1, that would be your mean plus 1 standard deviation. So obviously here, between this number here would be your mean plus a half a standard deviation, but I'm not going to label all of them. This number that goes here is your mean plus 2 standard deviations. And the last one would be your mean plus 3 standard deviations. So these numbers here give me your values above the mean. To the left, this value here would be your mean minus 1 standard deviation. This value here would be your mean minus 2 standard deviations. And this value here would be your mean minus 3 standard deviations. So all these values here are below your mean. Okay, so now we have these percents too. So inside here, between 1 standard deviation, so from here to here, from 1 standard deviation, I would add up all the scores, and that is 68.2% of the scores. From here to here, if I add up all the scores, that would be 95.4% of the scores. And then from the ends, here, from 3 standard deviations, if I add up all those percents, that's 98.9% of the scores. And that kind of makes sense because on the outside I have 0.1 and 0.1. Okay, so now let's talk about percentiles. If they talk about percentiles, they're talking about whether something is above or below a particular number and at what percent. So when they're asking about percentiles, you're always going to start in the middle. Because the middle is obviously 50, the middle is 50, is the 50th percentile. So put 50th percent. Now, to get this percentile, what I do is I take this number 19.1 and I add it to 50. So 19.1 plus 50 is 69.1. So that's the 69.1 percentile. To get the next percentile, this percentile, I add 15 to 69.1. And 15 plus 69.1 is 84.1 percentile. To get the next percentile, I add 9.2 to 84.1, and that's 93.3 percentile. And then so on. So the next one would be 97.7 percentile. And then the next one would be 99.4 percentile. And then there's one in here, right in here. That is 99.9 percentile. All right, now going around the other side. To get the value that goes here, you're going to take 19.1 and minus it from 50. So 19.1 minus 50 is 30.9 percentile. And then you're going to minus 15 from 30. And 15 minus 30 is 15.9 percentile. And then you're going to minus 9.2. And that's 6.7. And then minus 4.4. And that's 2.3 percentile. And then minus 1.7. That's 0.6 percentile. And then minus 0.5. And then the one in here, that is 0.1 percentile. Okay, so let's look at an example. All right, so I'm going to move everything up. Okay, so the first example says, if If the test scores on a particular math test are normally distributed and have a mean score of 75 and the standard deviation was 6, find the following. I'm going to look for these down here. All right, so the first thing I do is I write the mean is equal to 75 and the standard deviation is equal to 6 and a half a standard deviation is equal to 3. Now, why did I pick a half? Because our bell curve shows a half. All right, so I'm going to draw my bell curve. Draw it nice and big. Don't make it too small. Otherwise, you won't be able to see your numbers. I'm going to start right here in the middle. Because I know my middle score has to be the mean. And what's my mean? 75. Now I'm going to go a half to the right. So I always do my halves in a dotted line. So a half to the right, I do 75 plus a half a deviation. So this score here is 78. And now we're going to go another half a deviation, which is actually a full deviation. So now I do 78 plus 3, and that's 81. Now I go another half. So I add another 3, and that's 84. And then I go another half, and that's 87. So right now, this is a half. This is one whole standard deviation. One whole standard deviation from the mean is 81. Two whole standard deviations from the mean is 87. All right, another half. Another half puts me at 90. And then another half puts me at 93. All right, now we're going to work on the other side, below the mean. So we're going to subtract. So I start now subtracting. 75 minus 3. 72. Subtract another half. Subtract 3. 69. Subtract another half. 66. Subtract another half. That's 63. So now I'm at 2 standard deviations below the mean. Another half would put me at 60. And then another half, which is 3 standard deviations below the mean, is 57. Okay, so it says, number 1 says, what percentage of the population lies within 1 standard deviation of the mean? So 1 standard deviation would be from 69 to 81. Right, so I went from 69 to 81. So what I do is I take 19.1, 19.1, 15, and 15, and I add them up. So that is 15 plus 19.1 plus 19.1 plus 15. And that is 68.2%. So 68.2% of the scores lie between 69 and 81. What percent of the scores lie between 2 standard deviations? So 2 standard deviation would be from 63 to 87. Okay, that's why I did them in dotted lines, the halves and my full deviations in solid lines. So I'm going to add those percents in also. So this is 9.2 and 4.4. So I'm going to add from 2 standard deviations to 2 standard deviations. 4.4 plus 9.2 plus 15 plus 19.1 plus 19.1 plus 15 plus 9.2 plus 4.4, and that is 95.4% of the scores lie between 63 and 87. And now I want what percent of the scores lie between 3 standard deviations. So that means I want from here to here. So from 57 to 93. So I add all of this up. So I'm going to add also in the 5.7 and the 1.7 on both sides. So it's 0.5 plus 1.7 plus 4.4 plus 9.2 plus 15 plus 19.1 plus 19.1 plus 15 plus 9.2 plus 4.4 plus 1.7 plus 0.5, add that all up, and that's 99.8% of the scores. Okay, so flip it over, we'll take a look on the back. Okay, so it says the scores on the math test range from 50 to 97. The mean is 72 and the standard deviation is 7. Draw a normal distribution curve to represent this data. Okay, so I have a mean of 72 and a standard deviation of 7. Half a standard deviation would be 3.5. So let's draw the curve. Okay, so we're going to start in the middle here and we're going to label the mean 72. Okay, so I'm going to go a half. I'm going to go just a little bit here. There's a half, and that would be 75.5. Another half, which puts me at one whole standard deviation, is 79. And then let's go another half, and then that puts me at 82.5. And then another half, which is 2 standard deviations from the mean, is 86. And then another half. Another half is 89.5. And then 3 standard deviations from the mean would be 93. Okay, so let's go on to the other side. A half to the left would put me at 68.5. One whole standard deviation below the mean is 65. Another half, so 1.5 standard deviations below the mean is 61.5. 2 standard deviations below the mean is 58. Another half a standard deviation below is 54.5. And then another half, which is 3 standard deviations below the mean, is 51. Okay, so it says here for the first one, a score at the 60th percentile might be. So we're talking about percentiles. Remember, I labeled the top. All right, so I start with the middle because the middle is the 50th percentile. All right, so if the middle is the 50th percentile and I want the 60th percentile, I'm not going to label anything to the left because that's going to be below 50th percentile. I want to start labeling to the right. So I know this is 19.1. This is 15, and let's see, that's probably all I'm going to need. So right here at this percentile, I take 50 and I add 19.1. So that's 69.1. Okay, so that's really all I need. I want to know which one of these scores are at the 60th percentile. So could it be 80? Well, let's see where 80 would fall. 80 is over here someplace. Is that the 60th percentile? No, this is greater than 60. Over here is someplace in the 90s. So it's not that. Let's try 70. Well, 70 is over here. That's below the 60th. So that's actually below 50. Let's look at 74. So 74 is in between 72 and 75. So that's between 50 and 69. So possibly, let's just take a look at the last one, 60. Well, 60 would be over here. That's way below 50. So it can't be 60. So it has to be 74. Which of these scores can be expected to occur less than 3% of the time? Okay, so less than 3% of the time, we're talking about the ends over here. 3%, less than 3% of the time. All right, so at the ends, this is 0.5, this is 1.7, this is 4.4. So this total, this whole thing is more than 3%. So I really want this. This is about 2.2%. So I'm looking for here. Or it could be on the other side. It could be what matches on the other side, because remember, it's symmetric. So I want to see what score could fall in either of these two areas. Okay, so could it be 68? Well, 68 would be over here. So that's not less than 3% of the time. 68 is happening most of the time. Could it be 75? Well, 75 is in here. So no. What about 85? 85 would be in here someplace. That's not happening less than 3% of the time. So what about 94? All right, so let's see what 94 is. 94 is over here. This over here someplace. That's less than 3% of the time. Because from here over, that's 2.2% of the time. That's less than 2%, 2.2% of the time. So it has to be 94 since it's over in here. All right, and the last thing, I just have to move everything up, sorry. Okay, so the last thing says, what is the probability that a randomly selected score will be between 58 and 72? Okay, so I want between 58 and 72. That was my mean. My mean was 72. So I want between 58. Now 58, I know it's to the left of 72 because it's less than. So I want to know what percent, is between 58 and 72. This is also called area under the curve. Okay, so I want to find this percent. So I look at my chart from 58 to 72. So I have a 19. So there's 19.1, 15, 9.2, and 4.4. So I went from here, all the percents from here to there. So I add them all up. And what percent of the scores are between 58 and 72? That's 47.7% of the scores. Okay, so that's it. We'll practice in class. Have a good night.